star card equals deck, draw a random card. So I'm drawing a random card of the deck. And then I'm just going to say self.cards sub I equals card. Okay? So I've got this mutable array. It's always going to be non-nil. So this is perfectly fine. Okay? There's one problem here, though. What if we run out of cards? Okay? What if you pass a playing card deck here and you say 100 cards for your game? Okay? This is going to eventually return nil. Okay? And run out of cards. So we should check here and say if card, then we'll do what we normally do. Otherwise, self equals nil, break out of that for loop because we're dead. Okay? Question?
So how can you access the ith element of cards, even to set it, if you haven't put anything into cards?
So the question is, how can I access cards here to set it in this line of code when I haven't put anything into cards? Well, card starts out as nil. And then when I call the getter, self.cards right here is the getter, it's going to initialize it to an empty array, but it's mutable. So I can add objects here. Actually, oh, I'm sorry. You're right about that. Yeah, well, this is fine too. But maybe a better way to do this is to say self.cards add object card, because that's a little clearer. And in fact, you might be right. That wouldn't have worked. So this is a better way to do it. We'll just add cards to the deck. Okay, make sense? Sorry about that. I had a little different card there, but and actually, I'm not sure if that would work. Let me think about that. So you're saying insert object. Yeah, actually, that probably would work too, because you'd be doing insert object add index. It wouldn't be it would be just at the end of the array. That would probably work too. So you could do it either way, because self.card sub I, that sub I thing, it's really just calling a method. Insert object at substring index. That's what the method is calling. You can look at the documentation to see the name of the method it's calling there. But if you insert object at index and it's at the end of the array, I believe that'll work. But if you do it at 500, that's not going to work, okay? Because it can only grow the array as you go, I believe. Question?
Can you put different types of objects in the same array?
So the question is, can I put different kinds of objects in the same array? And the answer is absolutely. You can, and we do occasionally, and we'll talk about on Wednesday how you deal with that, right? How we manage the fact that we have different kinds of objects in there. But yeah, it's absolutely perfectly legal. Okay? All right, so there's that. And again, as I said, we could probably say at the beginning here, if self, we could also have an if count is less than 2, right? Then return nil. We could do that, check that as well. Okay? Okay, so let's do some of our other methods here. How about choose card at index? Okay, actually, let's do card at index, because card at index is super easy, right? This is card star, and notice if I start to type here, it knows that it's card at index, so it's going to complete that. I press tab to get there, and this one is just return self.card subindex. But you know, this is a public method. What happens if someone passes a bad index there, right? An index that's greater than the count. Are we just going to go ahead and crash here? One could argue that might be good because it'll help find the bug. Certainly some kind of assertion in here would be good. We'll talk about that later. But I'm actually just going to protect myself against it by saying if this index is less than self.cards count, then I'll return it. Okay? Otherwise, oops, if. Actually, we'll do it this way. We'll use the old question mark. Some people were asking about this. Okay, return question mark nil. Everyone know this question mark colon C thing? This is totally a C thing, not an objective C thing, right? Just like an if then. Yeah, question.
So without that guard, how does array access with these methods for the mutable array work? Without that index, without the guard, if you passed a large index, would it necessarily crash? Or would
yes. So the question is, what if I pass too large an index here? Would this crash? And it would. And what would happen is it would crash with the exception array index out of bounds.
Okay. So it wouldn't disclose memory on the heap or anything?
No, it would crash. It would raise an exception, array index out of bounds. Okay, and this array class would raise that exception. And we'll talk about raising exceptions. For now, until you go to this debugging thing maybe on Friday, for now, you're just going to see exceptions like that happen on your console. It's not even going to stop where the exception happened, which is unfortunate. But that debugging session, we'll talk about how to make it stop there. But that's what's going to happen. It's going to raise an exception. So that's card at index, really, really easy. And now let's talk about this other one, choose card at index. This is really the heart of our logic, because here's where you're choosing the cards. Here's where the matching actually has to happen and the scoring. Okay? So this is basically our entire logic is going to be in this method. So what do we need here? Well, they're choosing a card, so let's get the card they chose. And I'm going to call self card at index to get that card. Okay, so now I have the card that they're choosing here. Now, if a card that they chose has already been matched against another card, then I'm going to do nothing here. I'm going to ignore when you try to choose a card that's already been matched, successfully matched with another card. So I'm just going to say here, if card is matched, and actually I'll just say if not card is matched, we'll do something. Otherwise, we'll just do nothing. Okay, so I'm only going to match these cards if we're only going to try and match two chosen cards if the card you just chose was not already matched. Okay, that makes sense? Everyone see why I would do that? Okay, if it's already matched, you can't match it against another one. So now the question is, if the card is already chosen, then what am I going to do? Then I'm actually going to flip the card back over or unchoose it. So I'm going to say card.chosen equals no. Okay, so if you pick the card that's already chosen and you choose it again, it's going to unchoose it. So it's kind of a toggle. Choosing a card is kind of a toggles it on and off. Notice that we have the getter is chosen. Remember we renamed it in our header file with that getter equals is chosen. But the setter, okay, we don't use the is chosen. Setter is still chosen. Chosen is the name of the property. Okay? Everyone remember that from card? Hopefully you had to type it in so you remember it. So otherwise we're in here. In this case we're choosing a new card and we need to match it against other card. Okay? Let's say another card. Now our matching game only matches 2 cards. In your homework you have to extend this game to match up to 3 cards. Okay, that's going to be part of your homework assignment. But here we're only going to match one other card. So all I need to do here is look through all the other cards in my cards array up here. Right? This is my internal data structure. I just need to look through them all and find and go and see if there's another card that is chosen and not matched. And if it is, I'm going to try and match it against this card that was just chosen. So to search, I'm just going to go through my cards, for card, other card, in self.cards. Okay, I'm going to go through all the other cards, and if I can find an other card that is chosen and is not matched, okay, then bingo, I found another card to try and match. Now, there can only be one other one because I only do 2 card matches, and I'm always looking for that second match. So if it doesn't match, I'm going to flip that, unchoose that other one anyway. So I'm ready to go here. I've basically found the only other possible card that can match. Now again, when you do a 3 card match or an n card match, if you so choose in your homework, which might be a good idea, you might find a number of cards here. You might have to collect them somehow in an array or something so you can match them against each other. But here, I don't have to worry about that. So I found this other card that's also chosen. Let's match them. And I'm going to do that by saying match score equals the card that we chose up here, right? This is the one that the user is choosing. Match, colon, remember that's our method in card that matches 2 cards. It takes an array though, an array. So I'm going to have to make an array on the fly and put the other card in it. Okay? Everyone understand this line of code? I'm matching this card against this card using the match method in card. Okay? But I had to create this little array on the fly because match is actually capable of matching multiple cards, which is good because your homework's going to require that. But here I'm only doing one, so I just create this little blue @ square brackets thing to create an array. So now I've got this match. Now we've defined match, kind of the semantics of match are that if it returns non-zero, then there was a match of some sort. If it returns 0, no match. Okay, that's what match colon means. Okay, that's what we've just defined it that way in the semantics of our model. Probably we should have put a comment in our card.h that says match colon returns 0 if no match, otherwise how good a match it is, basically. So match should be returning high score if it's a really good match, and a lower score if it's not so good a match. Okay, that's kind of the semantics of it. All right, so what if it is a match or it's not a match? We have to deal with both of those cases. All right, so in the case that it is a match, then let's give ourselves that score. Okay, and both these cards match, so let's mark them both as matched. So we're going to say card.matched equals yes, and the other card.matched equals yes. Right? So they're matched, they're out of the game, we got some points. Now what if they don't match? Well, I told you if they don't match, I'm going to turn that other chosen card, I'm going to unchoose it, basically. So I'm going to say other card.chosen equals no. Okay? And also, I think I'm going to impose a penalty for doing this. Okay? I'm going to subtract something from the score. I'm going to call it my mismatch penalty here. And I can make a constant. Now, let's talk a little bit about constants. You know, this is C. Okay, so you're going to make these constants however you want. One way to do it is to say # define. Right? So I could say # define mismatch penalty. Oops. And we can make the mismatch penalty be, you know, the mismatch penalty is, what did I decide? I think something like 2. So I'm going to take away 2 points if you mismatch. So that's one way to do it. Another way to do constants is const. Okay, a static const even. Static const int mismatch penalty equals 2. Okay, so that's another way to do it. This is kind of as you prefer. The nice thing about these static const is they're typed, right? Whereas a # define is not typed, it's just substituting, okay? But here you've got a typed thing. You'll be able to see this in the debugger better because it's typed. But it's really kind of your own thing. I would just say be consistent about what you choose to # define versus what you decide to make a static const, okay? Totally up to you. You know, the other thing I'm going to do here is if you match, since I'm basically charging you 2 points if you mismatch, if you match, I want to give you a lot of points. So I'm actually going to give you a match bonus. Oops, match bonus. Okay, this is going to be another constant here. Put this up here. Actually, let's copy and paste this. This, paste. And I'm going to give you 4 times whatever your matching is because I'm giving you this penalty, so I want to give you a bonus if you actually match. So whatever the match score is, however good a match it is, you're going to get 4 times as many points if you match. Okay? And these are things that you would want to tweak, or maybe like possibly in your homework, you might even want to make these be public API to set these bonuses and penalties. Okay? Maybe that's something that wants to be settable, but we're going to make them constants for expediency in our game. The other thing we can do here is if we find this match right here, we can break out of this 4. Okay? And that's because we're a 2-card matching game. Once we found a match, we're done. Okay? We found another chosen card. We processed it. We don't need to keep looking for more matching cards. Again, if you have a matching more than 2 and you're collecting cards, you may not be breaking out of this loop down here. The other thing I wanted to do here is